Welcome to Funimation 3D, where science is everywhere. And today we're testing something super cool. Quick question, why can electricity travel through some things but not others? Like, why can a tiny light turn on when you touch a coin, but stay off when you touch a plastic spoon? Watch this. Click! The light turns on. Click! The light turns off. Whoa! Same circuit, different object. Can you guess which items will work? Let's find out with an easy at-home science test. Okay, first, what are we even testing? Electricity is like a team of tiny movers. We can imagine them as tiny moving dots, or tiny marbles rolling along a path. Those tiny movers are called electrons. Electrons love to travel through some materials. In other materials, they get stuck and can't move easily. And that's where our two big words come in. A conductor is a material that lets electricity travel through it easily. It's like a smooth slide for those tiny marbles. An insulator is a material that blocks electricity. It's like a wall that stops the marbles, so conductors help electricity move. Insulators stop electricity from moving. Most metals are great conductors, like copper, aluminum, and steel. That's why wires usually have metal inside. And materials like plastic, rubber, wood, and glass are usually insulators. That's why wires usually have plastic on the outside. Metal inside to carry electricity. Plastic outside to keep you safe. Smart design. Now, a quick note about water. You might think water conducts electricity. And yes, everyday water often does, because it has tiny bits of minerals and salts mixed in. Those minerals help electricity move. But super pure water is different. It doesn't conduct very well. Most of the water we drink is not pure like that, so we treat water like it can conduct. And that's why we're not testing liquids today. Safety first. Now let's build our easy conductivity tester. Remember, ask a grown-up to help you with this part. And we only use batteries. No wall outlets. No plugging anything into the wall. Ever. Here's what you need. 1 small battery pack or 2 AA batteries. A tiny LED light or a small flashlight bulb. And 2 wires. If you don't have wires, a grown-up can help you use strips of aluminum foil as test arms, but wires are easier. Now imagine our tester like a little electricity bridge. The battery is the power source. The LED is the light that will turn on when electricity can travel. And the 2 wires are like 2 hands that are almost touching, but not quite. There's a small gap between them. When we put an object in that gap, we are asking one big question. Can electricity travel through this object and complete the path? If the path is complete, the light turns on. Ding! If the path is blocked, the light stays off. Here are the simple steps. Step 1. Connect one end of the battery pack to one leg of the LED. Step 2. Connect the other leg of the LED to one wire. This will be test arm number 1. Step 3. Connect the other end of the battery pack to the second wire. This is test arm number 2. Now you should have 2 free wire ends that do not touch each other. That little gap is where the magic happens. If your LED doesn't light up during tests, it might be flipped the wrong way. LEDs have a direction. A grown-up can help you flip it around. Now for the rules. Super important. No wall sockets, only batteries, no wet hands. Do not test liquids. Do not poke anything sharp. And ask a grown-up to help the whole time. Okay, scientists, it's game time. We're going to predict first, then test. Every time I say an object, you guess. Conductor or insulator. Then we test and see if the light turns on. Ready? Here we go. First object. A coin. What do you think? Conductor or insulator? Most coins are metal, so they should conduct. Place the coin between the 2 wire ends so it touches both. And click! If the light turns on, that means the coin is a conductor. Nice! Next object. A paperclip. Paperclips are metal too, so what's your guess? Touch it to both test arms. Click Click. If the light turns on again, conductor confirmed. Next, aluminum foil. This one is super fun because it's thin and shiny. Touch the foil to both ends. Click. Aluminum is a conductor. That's why foil is great for quick tests. Next, a key. Most keys are metal, so conductor? Touch both ends with the key. Click. If it lights, that's another conductor win. Next, a metal spoon. Guess? Metal spoon should conduct. Touch the spoon. Click. If it lights up, that spoon is a conductor too. Okay, we've tested a bunch of conductors. Now let's try some tricky ones. Next object, a plastic spoon. Plastic looks smooth and shiny sometimes, but is it a conductor? Let's test. Touch plastic spoon to both ends. Nothing? If the light stays off, that means plastic is an insulator. It blocks the tiny movers. Next, a rubber eraser. Rubber is usually an insulator. Let's see. Touch the eraser to both ends. If the light stays off, yes, rubber is an insulator. That's why rubber is often used for safety coverings. Next, paper. Paper seems plain, but what will it do? Touch paper to both ends. If the light stays off, paper is an insulator. Most dry paper does not let electrons travel easily. Now, cloth. Try a piece of cloth, like a small towel or a t-shirt. Touch cloth to both ends. If it stays off, cloth is usually an insulator too, especially when it's dry. Now let's do one that can surprise people. A wooden pencil. Most people look at a pencil and think wood, so they guess insulator, but pencils have a special core. That dark line inside a pencil is called graphite. It's what makes your pencil write. Graphite can allow electricity to move, even though the outside wood does not. So here's the challenge. Don't test the wood part. Test the pencil tip, the graphite part. Touch the pencil tip to one wire end and touch the graphite line to the other end if possible. Or have a grown-up help you touch both test arms to the graphite. Now, does it light up? Sometimes it lights a little. Sometimes it's weak, but if you see even a tiny glow, that means graphite can conduct a bit. That's a cool surprise. A pencil can be a weak conductor because of graphite. Next optional object, glass. If you have a glass item and a grown-up says it's safe to use, you can test it carefully. Touch it gently. Don't drop it. Does the light turn on? Usually no. Glass is usually an insulator. Awesome work, scientists! Now, quick celebration moment. How many of your predictions were correct? If you got most of them right, you're doing great. If you got surprised, that's even better. Surprises mean learning. Now it's time for myth busting. True or false? All shiny things conduct electricity. Think about it. True or false? The answer is false. Some shiny things are still insulators. For example, shiny plastic can look like metal, but it does not conduct. Shiny does not always mean conductor. We test to be sure. Second mythbuster. True or false? Wood always insulates. The answer is mostly true, but not always. Dry wood is usually an insulator, but if wood gets wet, it can let electricity move a little more because water can help carry charge. That's one more reason electricity and water are a bad mix. We keep our tests dry and safe. Now let's connect this to real life, because conductors and insulators are everywhere. First, wires. Inside most wires is metal, usually copper. That metal is a conductor. It lets electricity travel, but the outside is plastic or rubber. That's an insulator. It blocks electricity from touching your hand. Second, phone chargers and cables. They have insulated coatings too. That's why you can safely hold them. Third, oven mitts. Oven mitts are insulators, but for heat. They block heat from burning your hands. Different kind of energy, same idea. Insulators help protect you. Fourth, birds on power lines. You might wonder, why don't birds get shocked? Here's the simple answer. If a bird sits on one wire and does not touch anything else, electricity usually does not have a reason to travel through the bird to somewhere else. Electricity loves a path from one place to another. If the bird is not making a big path, it's usually okay. But if a bird touched two wires at the same time, that could be dangerous. That's why we never go near power lines, ever. Fifth, rubber soles on shoes. Rubber is an insulator, so it helps reduce tiny shocks from static electricity sometimes. Not always, but it can help. And that's why different materials matter so much. All right, mini recap time. Let's say it in simple lines so you can remember it easily. A conductor lets electricity move through it. An insulator blocks electricity. Metals like copper, aluminum, and steel are usually conductors. Plastic, rubber, wood, and glass are usually insulators. A simple battery circuit can test objects safely. And we always use batteries, stay dry, and ask a grown-up for help. Before we go, I have a final challenge for you. Find 3 new objects in your home and predict conductor or insulator. Maybe a zipper, a hairpin, a crayon wrapper, a toy, a button. Test them with your circuit and keep score. Which object was the best conductor? And what was your biggest surprise? Thanks for exploring science with Funimation 3D today. If you had fun, please like this video, share it with a friend, and subscribe to Funimation 3D for more fun facts and cool experiments for kids. And comment below. Tell us your best conductor and your biggest surprise.